Hi, here's another coffee and science video. It is 8 o'clock at night, so I don't have any coffee in here or else I wouldn't be able to sleep tonight. But I wanted to create a video a little early today because I was doing some reading on a couple of different sites I usually go to. So Phys.org is very reliable. They have cutting edge science articles, science research in almost every discipline. I've been going there for about since I was 12. So I've been going there almost 16 years now. And I found a really cool article today. I wanted to touch base and talk to you guys about it. It's coming from one of the EU programs, and I want to give you some guidance how it fits into our industry within the United States and what this means going forward. Um, so I wanted to tell you guys that this is some pretty cool research, and it's essentially trying to replace silicon-based server racks with quantum server racks. I definitely look into it. It's part of their flagship quantum technologies program. It's supposed to fit between 30 and 50 square meters within the lab. And what's interesting about this is they say it's up to 50 quantum bits or qubits, depending on how you want to say them. And here's a picture of it. It looks pretty usable. There's two of them. 50 qubits, what does that actually mean? What's quantum volume? Why is that important? I mean, if you're coming off the street and you don't know as much about quantum sciences, information sciences, or you haven't been tracking the field for a while, all I see is really tall refrigerators. So for the C-suite managers and for everybody else, why is this important? Well, this is very important because of some things that happened in 2019. That's an email I sent um, to one of my family members back in 2019, and it essentially was looking at a few things. I don't remember what I said in there, but some of the things that were interesting, I guess, were this line and these these three lines. So what happened in 2018 is Google broke away from IBM. IBM was leading at that time. I believe they had 49 qubits, and Google stomped them with 72 qubits. And they released it in the second quarter of 2018. They called it Bristlecone. So why that's important is that's the first quantum computer that reached quantum supremacy back in 2018. However, Google didn't have enough resources in house to determine if they actually reached quantum supremacy. They had to reach out to the good people at NASA down the street at Moffett Field, Ames Lab, and they asked them, hey, we have this research. It looks like we broke quantum supremacy. Can you verify and do the testing? At the time, I actually reached out to Ames Lab to try to determine which benchmarks they were using. Never heard back from them, but that was in 2018. So you go back a little bit in time, 1 year, so 2017, and IBM reached out to Lawrence Livermore National Labs, which I believe it's in Berkeley. So it's not the same NASA folks at Moffett Field, but these are a little further up. Not further up in rank, but from my understanding, just further up along the way, down the road. And so what they did is they really wanted to determine the measure at which quantum supremacy would start and classical computing would, I guess, end. So it's not enough to do a theoretical max min bound of quantum supremacy versus classical computing. You have to actually simulate it and determine what a quantum computer can do and what a classical computer can do. However, if you go back to the 50s when NMR was really getting big on nuclear magnetic resonance, they spun some disks with superconducting coils. So basically they used quantum mechanics to make this thing run without energy being put into the system. So it was a closed system. And some speculate that it's still running today. So if you were trying to simulate quantum supremacy, at which point classical computer would be um, too slow to compete with a quantum computer, you would never be able to actually determine that state based on just running it forever. So what we do is something called um, theorem by induction or induction theorem. So based on 1 plus 1 equals 2, 1 plus 2 equals 3, you can determine then that 3 plus 1 equals 4. So what that's saying is, based on the classical computer running for so long, you're essentially using mathematical induction to determine that, hey, it's not going to reach its point, and therefore the quantum computer is better. And so in 2017, IBM was ahead theoretically of Google, and they were able to simulate with Lawrence in Berkeley 56 qubits were, I guess, the classical maximum. And so the minimum would be, for quantum supremacy, 57 or so. 57, 58, doesn't matter. So Google's research coming out in 2018 is very, very important because at that point, you are reaching a level of quantum supremacy that is unparalleled because you're looking at a power of 2. And so what's happening is since 2018, we reached quantum supremacy going forward. And then I talk about different quantum volumes and extrapolations, and some of IBM's research was really cool in 2017, 2018, looking at quantum Moore's law, but that's not important here. What's important, and for the C-suite managers and for people that really don't care about the ones and zeros, they just care about why is it important? Why am I looking at a fridge? So in this case, in I'm not sure what year it was. I guess it might have been around the same year, 2018 or so. I don't know. That was a while ago. But Google put up their Sycamore processor to test whether they reach quantum supremacy with NASA. And what that was is they were testing 54 or 53 qubits. But they didn't realize that if they would have talked to IBM or at least read their research, then they would realize that you could simulate 56 qubits. So Google wasted some money there, but whatever, they can throw as much money away as they want. So if in actuality, instead of testing 54 qubits, they tested 72, then NASA would have found out that they were actually, in fact, testing quantum supremacy beyond a scale that's measurable by any tools that we have. So they had to develop new benchmarks for it. That's why I reached out to them. And so what's happening is 53, 54 qubits are still significantly under the quantum supremacy bound. So we're still talking about theoretically, like, I guess if you were looking at 54 qubits, then you're 3, 4 qubits out. Now, Alibaba threw a wrench, and that same year they said they tested a simulated quantum computer with 81 qubits. Who knows? Sometimes I think they're just full of it, but essentially what happened is instead of the 72 qubits being quantum supremacy, now it's 81. However, in 2019, after this occurred, let me pull it up. So this is a 2019 article. Google confirms quantum supremacy, and they talk about the 54 qubits. In actuality, they were talking about 72 qubits because the IBM in Berkeley was able to determine that it was actually 56 qubits that can be simulated. So we're talking about 57 or 58 qubits that are quantum supremacy. Doesn't matter. Essentially, Google said, Alibaba, you're wrong. It's 54. And so today, Bless IBM. I finally get to enter the quantum realm. Been researching this since I went to my training school within the military. So I've been researching this for the last 4 years. I'm excited to help IBM get started and get moving forward because right now they're preaching 32 qubits. Sorry, let me retain that question and retract it. They're talking about 32 quantum volumes. And so what does that actually mean? I mean, the qubits are on the side and it shows, what that is doing for a public server. If you go to some of the research that was occurring in 2017, they talk about the quantum volume of 17 qubits being 35. So what they essentially have done, they've error corrected and made the qubits more usable. And so there's different ways to make quantum volume increase. And so instead of increasing to 17, they decreased to 5, but increase the fidelity of the gates through error correction and essentially made the volume bigger. And so why is this important for the article that we originally talked about? Well, we're talking about 50 qubits here and for servers that can be deployed universally. And that's pretty fascinating because even though they're super far behind Google and IBM, Rigetti, basically anybody else, what they're doing is they're providing an avenue to provide commercially available quantum servers that can be solicited through APIs and that are it's just under quantum supremacy, so it's like a supercomputer that we're aware of today, but it's not anything to shake a stick at compared to some of these others. Just something to be interested. Once again, I've been researching this and looking at this stuff for about 4 years. Been reaching out to different agencies like NASA. Been reaching out to Google and IBM for years, trying to get started. I was in the military for 4 years. I couldn't do it. Now I'm out and I'm pursuing my dream. Started a business. Got onto the quantum educators program for IBM, and I can't wait to start helping those guys out. Sorry, I'm not allowed to say that anymore. I can't wait to start helping those individuals out, and can't wait for what the future holds. So their quantum volumes are a little watered down right now on publicly available servers for IBM. They're behind Google, Honeywell, and a couple other companies. And I'm excited to potentially help them get back on the throne because originally quantum information systems and quantum communication came out of IBM with Charles Bennett. And so they have a long standing history. It's not always about the legacy, sometimes it's about what's happening now. And it'd be nice to start getting getting those individuals back to where they're supposed to be. Once again, I hope you tune in and listen to some of my coffee and science videos in the future. I'm still working on it. It's going to improve, but I look forward to delivering you random bits of science every day. So have a great day, have a great weekend, and see you soon.